All right, I guess we can begin. Thank you all for joining in. This session will be hosted by Pedro Costa, the engineering design lead at Pi EV 2022. Pedro, you can begin with your presentation whenever you're ready.
Hi, everyone. So as presented, my name is Pedro, and I will be the design event lead, and we'll start this Q&A session. So let me again set up my presenter's view, and we can start. So a little bit about myself. I was born and I live in Portugal, which is a country in the most eastern part of Europe. I'm an electrical engineer, and I've been a part of somehow in Formula Student for almost 10 years. I was a part of a Formula Student team in TU Lisbon, the one you can see basically on the background. I was part of this team for almost 4 years. And more recently, in the past 5 to 6 years, I've worked as a judge. The first time in Formula Bar was in 2019, and I've been since 2017 collaborating in Formula Student Spain. Currently, what I'm doing is pursuing a PhD in power electronics. But this is not so much about myself. So let's get into the part that matters, which is the engineering design. And I would like to remind everyone about the purpose of the engineering and of the engineering design event. And I think that one of these two sentences which are in the rule book or the rule book for the Pi event sum up pretty well what we are expecting. And so the purpose of what we want to do with this is to evaluate the amount of effort you put into the design specifically of your EV powertrain. And a second one that I decided to pay close attention, because it's something that I see recurrently every year, not being approached very correctly by the teams, which is, you talk a lot about proprietary components. One of the main examples of this is, for example, the BMS system. And we don't really want to know what the manufacturer did. We want to know how you used it. So focus more on the application that you used. And this sentence again sums up pretty well what I want to tell. And I will read it because I find it very, very important. And it says, proprietary components and systems that are incorporated into the design as finished items are not evaluated as student design unit, but are only assessed on the STEAM selection and application of that unit, being this last sentence the most important part. So the part that we are very, very interested is the assessment that the team and the application that the team makes of these parts. So since the purpose of this is to be a Q&A session, I've already gathered the questions that you've submitted previously, and unless anyone has any opposition, I think we can move on to the questions. So here I go. Okay, so the first question, and remind yourselves that I'm Portuguese. I will try to, if I misspell your name, please call me out on it, because it's the way I learn as well. But this was proposed by Ankit, and the question is, in supporting document reports, what data is required to validate I'm guessing that MIL is the model in the loop, but if Ankit is here, he can clear it out for us, but I'm guessing it's a model in the loop for state of charge and for state of health of a BMS. Well, this is a very, very specific and particular question. By default, so when you need to present data and the data that you want to place on your supporting document, you should always keep this idea in mind. You should present the minimum amount of data that shows what you are claiming. So if you claim that you have a model for a state of health and a model for a state of charge, and you want to show that your module is accurate enough, you should show the minimum set of data, or the most understandable set of data that proves your claims. It is hard for me to answer this question in a more detailed way, because what is required to validate what in the model in the loop? There are several things you can validate, but I'm guessing that from the way the question is highlighted, I would say that my comment or my suggestion would be normally this type of models are validated with with measurement data from the real system, and then try to find some correlation with your model. I don't know if Ankit is here.
No, he doesn't seem to be
Okay.
in the meeting.
So we cannot clear us if the intent of the question was exactly this. But I hope this clears. So I guess we can move on. And Gilkara asks us, in the design of the catch can, do we have to make a 3D model on where the catch can will be located, or a brief explanation will do? Well, it's not mandatory that especially for this design event, which is more conceptual, that you have everything on your card. So if you explain to the judge where if the judge finds interest on how your cooling system is set up, and if it somehow reaches to the point where you want to show, or you have some new development, or you have some innovation regarding the design of the catch can position, or you've put some design effort into it, then you should show it. Obviously, you can just explain it, but if you can show it on 3D, I would say that is better. You can do both, but obviously having the 3D is better. I don't know if that clears the question as well. Also not sure if Gilkara is here. Okay, so we'll move on. So Cara as well asks, can we use glycol as a coolant option, as we are allowed to use oils as a coolant? Well, as to my best of knowledge, and specifically when we talk about glycol is basically the family of all alcohols. So it's a very, very generic question. So what I'm thinking is they probably mean something like antifreeze, which is glycol ethylene or something close to that. And if that's what they mean, then by direct consultation of the rules, I wouldn't classify this as an oil. And what the current rules for Formula Bar 2023 state is that you can use plain water, you can use air, and you can use oils. So I would classify this as a no. But unless you specify better what you mean about glycol, because there are some glycol oils, so I don't think a cooling is a normal application. I think that the short answer would be no. But since Gikara is not present, I'm not sure if we can clear this. So maybe I'll move on. So then Rafif asks us, what are some validation methods for torque vectoring, and what parameters are to be reported in the results? So again, very, very specific question. There are several types of validation methods, but I would also say that this is also the job of the team and the job of the team members to find out how do you validate the process that you've made. I can give some pointers, and the ideal validation method for whatever influences the performance of the car is the direct measurement either of the efficiency of the car or the in this case for torque vectoring, track times that you can obtain. Can the car actually be faster when you use torque vectoring against not using torque vectoring? Considering that you might not have the vehicle ready, and since this is basically concept, if you have a model of your car where you can implement, so it would already have to be a model which would be suitable to simulate the behavior of the car with different tractions across different wheels, and obtain different track times, then you can validate through there. And what parameters are to be reported in the results? Well, that would be dependent on the type of validation that you are doing. I don't know if Rafif is here. Maybe not as well.
No, he's not here either.
Okay. But in a general terms, these types of questions. So what are some validation methods? Well, that's for the teams to find out and for us to judge. It's not that I cannot give some pointers. If Rafif was here, it would be easier. But in general terms, when you want to validate something, there are specific engineering processes which you should get familiar with, and it's the responsibility of the teams to find that out and to show that the work they've placed and the engineering process that they've placed in the design makes sense and is in some way validated. So since Rafif is not here as well, I will move on. And Rafif as well asked what is power density in the motor controller packing and packaging, and what is the difference between it and compactness. Well, a thing can be very, very compact. So for example, your motor, including motor casing and including the cooling of the motor, can be very, very compact, but the motor can just be 1 kilowatt. So when we talk about power density, we are talking about, if we're talking about volumetric power density, we are talking about what is the power divided by unit volume. And if we're talking about a massive power density, then we are talking about power divided by the total mass of the system. And this is a better indicator this indicator does not depend on power, because it would be expected that for the same type of motor using the same design approaches, you can, if you double the power and if you use exactly the same design methods, you would expect to also increase the volume and mass. So this metric of power density helps us judging different setups, normalizing to the power. I'm not sure if, yes, Rafif was the same question. I'm guessing this would answer this question is pretty straightforward. And when you judge compactness would be measured in unit volume. So moving on, what kind of simulations of motor should be added to the engineering design presentation? Well, it's a very, very generic question again. It depends on what you want to show. It depends on how much how much effort did you place into any model of the motor that you use to simulate. But I would say that there are, when you are talking about simulations of a motor, efficiency would be the first things that pops to my mind if you want to show some results about efficiency or how you model the losses of your motor. You can also correlate the efficiency across the map of the motor to the expected working points throughout, for example, a track. If you can simulate the track, you know what is you already know beforehand what is the gear ratios that you have in your car. Then you can throughout the track point out what is where the motor is working in terms of a torque velocity curve. So you can correlate then where if you are working in efficient regions of the motor, or if you are working in inefficient regions of the motor. This is always a good thing to show, and I always like to see simulations that show where in the curve of velocity and torque do we have our motor mostly working throughout most of the time for a specific track. I'm not sure if Sahid is here.
No.
And so let's hope this answers this question. So Said as well asked us, should we add the vehicle dynamics related calculations to the design report, to the supporting documentation? I would say this is a pretty obvious question, the pretty obvious answer, which is yes, you should. If you have something to show regarding your vehicle dynamic simulations or calculations that led you to some design decisions, then by all means show this in the supporting document. Okay, so here is a very specific question. I've looked at this question a while ago. Maud asks us, why don't we use body cam chassis instead of tubular truss type? That is a question for you to answer, I guess. Most teams do use tubular truss, and some teams use monocoques. I'm not sure exactly what type of answer you are expecting in this question. But well, as long as you design a chassis that is compliant with the formula student and formula Bharat rules, then you should be fine. That is mostly what you should concern about. Is you do have to there are rules and you need to comply to them. And Moad also asks us, what are the key points to keep in mind while designing a chassis? Well, this is exactly the type of questions which we are probably going to make to you. Obviously, I can give some pointers, but this is the type of questions you need to answer throughout the design of your car. And well, structural integrity, packaging, among many other things, are very important things to keep in mind while designing the chassis. Mainly because it integrates with almost everything else in the car. You need to pack the batteries, you need to pack the containers, you need to have the driver, you need to comply with the rules. There are several points you need to address, and you need to do this while keeping the structural integrity of the car. I don't know if this answers your question, Maud. I'm not sure if he's here.
No, Pedro, he's not
Also
here.
no. Okay, so let's move on. So Deeptash asks us how to prevent foreign substances like dust and humidity from getting into an air-cooled battery pack while keeping sufficient airflow into the system. Again, very, very specific question. And once again, one of those that you have to answer by yourself. I can give, again, some pointers, but I can tell you, for example, if dust is a concern, engines and typical internal combustion engines have been inputting air to the, have been consuming air that is very, very dusty, and they still manage to work. And the trick is very, very simple. You can look how do internal combustion engines do get their intake air, and you can apply a similar ideas to the cooling of your battery pack. Maybe we can move on unless Deeptash has anything to add. Okay. So how to move the center of gravity to the center if we'll mount the battery at the back of the vehicle? Again, that's a question for you to decide. I understand getting the center of gravity to a point is a vehicle more to the center of the vehicle might be a vehicle dynamics goal, and it's up to the design of the entire team to do their packing and do their components to get the center of gravity where they want. My suggestion is always think that besides the battery, you still have, depending on the weight of your battery, there's still at least one more thing that is very, very heavy that you need to place in the car, and that's the driver. So you can always play with the position of the driver to help you move the center of gravity. And I guess those were the questions that were on the document. I hope I didn't miss any one of these. Any one of the questions in the spreadsheet. If there are any more questions, we can answer those. I would just remind everyone that the deadline for the EDP and the support document is May 30. So always remind to keep up with the deadlines, not to get any penalties. I'm not sure if we have any questions okay, we have a question, I guess, on the chat. So the question is, do we need to add detailed simulations and calculations we have done for the validation and selection of the parts? Yes, you should add your calculations and try to add them as minimalistically as possible. So you don't need to have a lot of intermediate steps on your calculations. Show the main idea behind the calculations, show the assumptions that you've made, and show the results for the selection of that part. And make that clear and organized in your support document, and you will be fine. I hope this answers your question. If you have any more questions, feel free to turn on the mic and just ask away.
There are no questions on YouTube yet. We'll just give it 2 more minutes. Students, if you all have any questions, you all can ask Pedro right away. Or if we do not get any questions in the next 2 minutes, we will end the session.
Yeah, before we end the session, I can we can have a brief talk about the rubric, and then we can end the session if there are not any more questions.
Yep.
Or we can also go to the rubric right away.
Yes, I guess that would be good.
Yeah, so let me open the rubric. So hopefully you can see the rubric.
Yes, it's visible.
Yeah, good. So, okay. So we can talk a little bit about the division of each score. And for the overall concept, we are giving 20 points, 50 points for the accumulator, 40 points for powertrain, 25 points for electronics and auxiliaries, and then 15 points plus 20 for your presentation and Q&A. So clearly one of the major points in your presentation is the battery pack. I also know that for most teams this is where they put out the most effort, but remember that the remaining components of powertrain and electronics are also worth a lot of points. And I always see teams devoting a lot to the accumulator, which is good, but they also, you looking at the rubric, you also need to remember that you need to devote parts of your presentation and support documents to address the other points of the rubric. So keep that in mind. So in the overall EV concept, other than just completing the DSS, the judges always look at the overall idea. Does it make sense? Does the whole car make sense as a one? Because there are some cars where you feel the team is communicating, the battery selection, the motor and the inverter selection make sense. The voltages work together when they select the battery voltage. The components are sized well and they appear designed towards the same goal and with the same design ideas. And this is basically what we judge in the overall package. If a package is sometimes it can have a good battery, but then barely mentions the powertrain or what is the interface on how did the motor and inverter influenced the decisions that you've made on the accumulator, then then we tend to judge less on this. We tend to judge the sensibility of the overall package on the downside. Then we get into the accumulator. And on the accumulator, we break this down into energy and power calculations. And I think this energy and power calculation is something that some teams already master very, very well by my experience, but others still struggle with estimating clearly what is the required energy and power for the battery. And remember that it is very important for a judge to see that you are sizing your battery correctly, because this will influence greatly the rest of the car. If you do not have enough energy, then the car needs to go slower. If you have way too much energy, then the car will be heavier and as such will be slower. Then it is important to provide a clear metric on how you've calculated the energy and power for your pack. This can either be handmade calculations that make sense, or can either be complicated simulations. Either way is fine, as long as you understand what you are doing and the engineering process, the selection process behind those values are sound. So then we get into cell modules and BMS, which relates more on how you pack the cells, how your BMS integrates into this pack. Where do you measure? Temperatures? Always remember to show where do you measure your temperature, what are the limits, what is the packaging. Give figures of merit. So figures of merit are indicative, can be indicative through all this process. So the cell has a given energy density that you can then show, okay, we've done a pack and this pack has this energy density, or it weighs this much, and compared to the previous year, we've managed to reduce this much. Use figures of merit, those being weight, being energy density, the total amount of energy, because you've noticed, for example, that in the previous year you had to increase. I think that I would say it's very, very good is always give some figures of merit throughout each entire section to compare, to show, to indicate how good your design is. So then we get into thermal management. Another thing that I think some teams are already as well mastering quite well, but others are still struggling. There's a big gap into, I think there are some teams that are doing this very, very well. Then we still have a considerable number of teams, from what I've seen the past years, that still struggle into, I wouldn't say that they necessarily have a car that is not capable to cool the batteries, but their design is very confusing. So, and it's one of those things that you can detail very, very well. Just say, what are your assumptions when you are designing, when you are making the thermal management, and the assumptions must start somewhere. In particular, you must know how much energy are you going to remove in the end, how much power instantaneous you're going to have to remove from the battery, and give those figures and proceed from those figures to show that whatever the system you have designed is capable to withstand the heat load that you are expecting. And justify your assumptions. How did you get to the value? So sometimes you say, okay, we are assuming that the battery is 80% efficiency. That means that 20% of the energy must be removed as heat of the energy stored in the battery. That might be true, but you need to show it. You need to show, okay, it's 20% because we assume this, it has this internal resistance. We are expecting this type of losses with this type of profile. Battery auxiliaries, also a region that I think most teams tend to forget. It's still worth 2.5 points, and I think it's very easy to devote one page on their support document to show the sizing, that the sizing of all these components, fuses, maintenance plugs, high voltage connectors, cable sections in a single table, just specifying what is the current that you are expecting to have on each of these components. In a single table, you can explain all this and have maximum points. If everything is dimensioned properly, you can have maximum points in this section with just a single table. Well, charger is pretty charger and is pretty self-explanatory. And then design for safety. Design for safety, sometimes it's hard to devote just a single section, because throughout all these topics, safety can be a concern. Just make sure to, I think it's more or less detailed on the description. Is actually very well detailed. You can talk about the isolation, the type of materials that you select. Make sure when you make a decision of selecting a given material or sizing this with a given safety margin, to state either in your presentation or in your support document that safety or some reason related to safety is the reason that that influenced your selection process. Then we get to powertrain. I think that motor selection is something that most teams are already doing fairly well. And the problem is the controller selection. And just stating that, okay, this was the controller or this was the motor controller that was recommended by the manufacturer, I think it's insufficient. Because, okay, it was recommended, but maybe for your purposes, for the profile that you are expecting, maybe there's a better one. And why not exploring? Even though in the end you can use the one that was recommended, you should explore. And you should also know how it works. So it is very, very common for students to know the chemistry of the battery and how it works. It is very common for the students to know how a motor is composed and how it works. But I found out that it's also very, very common for students not to know how an inverter works and how the motor controller works and how the motor controller influences the performance of your motor. And it is also very, very important. And regarding this powertrain section, the remaining I think is very self-explanatory. Gear ratio selection, remember to always justify your gear ratio, very, very important, and the judges always look for it. It's worth one quarter of the section of powertrain, so give some attention detail to that. Then torque vectoring and regenerative braking, if you have, you should also give some detail into it. Then we get to electronics, an area that is also often forgotten throughout the document, or it gets to the very end and then you only have 1 minute of presentation. Look, it's still worth 25 points, so make sure to devote some time to it. And my advice regarding the way you approach electronics is think very much on this first topic. If you think a lot on your system architecture and how it works, and if you can explain this very, very well, the rest of the topics will appear by just as you explain your architecture, the shutdown circuit and the T-cell and the HVD, all the components that are rules related will appear naturally because they have to be included in your architectural design. The packaging and selection of hardware will also make more sense if you explain what the objectives and how your system is structured. And in the end, this is like the bonus. If you have driver interfaces, if you have data logging, or if you have telemetry, you should highlight them, and you should give figures of merit also for these sections. The one I would highlight the most is driver interfaces. A lot of teams have driver interfaces, and they say they want to provide a lot of information to the driver. That's perfectly fine and good. Make sure your driver wants that information, and make sure that information is useful to your driver, and explain why. Why do you think that information is going to help them? Because the driver is mostly there to drive. If you flood him with information, he's not going to use a lot of information. He's not going to use most of what is available. And if you completely flood, as I've seen before, dashboards which have all the setup points of the car, the driver is not looking at that when he's racing. So make sure you are providing information to the driver that he actually wants and that actually helps him. And showing this is very, very good. Then finally, the presentation and the Q&A. My advice for your presentation is prepare it. Make more than one version of your presentation. The thing that I like when I see your presentations is that most of them are already presented very logically. So I wouldn't say that is a problem for most teams, but always keep in mind to when you finish the presentation, listen to it several times and see, is this the best way is this the best thread to follow? So maybe it doesn't make a lot of sense to present the cooling system right away and only then present the batteries, which had to be designed before, and the cooling system had to adapt or had to know or already had to have some considerations about the battery. So make sure it follows a logical design order for the judges to be able to follow along, so that they don't need future information that they don't still have in the presentation to understand what you are presenting now. Then about the presentation itself, most of speaking with clear voice, I don't think it's been a problem. I think most of you already have fairly well mastered your presentations. Just as a comment on style that I've noticed is, be careful when you have different presenters, which is most of the teams, to match the volume of the voices, because sometimes we have a presenter that the voice is spot on, then it becomes very, very loud, and then it becomes very, very low. Just listen to your presentation in the end, and we live in the most digital age ever. So there's hundreds and hundreds of programs that will help you to edit your video. Make sure you just edit so that the volumes of the voices remain constant throughout the presentation. Then about visual aids, remember you are going to be engineers, so give visual aids as engineers. So make sure that when you give you provide information that is useful on your graphs, on your tables. Make sure on our graphs to have units so that they are clear. Do not place graphs where we can barely see. We as viewers of the presentation, sometimes you present a graph or the resolution is too low or everything, because you want to put so much information there, then everything gets very, very small and we can't understand anything. Basically make sure that your visual references, your visual aids are understandable. I want to look at it and use it to reinforce or to corroborate something that you are saying at that moment, and make sure it clearly states what you are saying. Then for the Q&A session, my only advice would be have a presentation ready, but that doesn't mean you have to follow the presentation. Sometimes the judges will ask a question that is unrelated, or they will explore something that if you've already done a presentation before, the judge has already seen the presentation and the support document, so he might have very, very specific questions. It is good for you to have some line of explanation ready for each subject, but be ready to be very, very efficient and quickly, that if suddenly I'm asking about thermal management and you are showing me something, you are sharing the screen and showing me some detail about thermal management, if in the next moment I ask something about the cell selection process, make sure you are efficient and ready and you have your things organized to quickly move out to the cell selection process, so you can maximize the amount of conversation you have with the judge, and as such maximize the points that you will get. I don't know if you have any questions about the rubric. Feel free to ask away. I think that we have one more question in the chat. And Aram asks if should we produce a model in which our powertrain is mounted in our chassis? I don't exactly know what you mean, Aaron. Are you talking about like a simulation model? Are you talking about just a 3D model? Can you clear out this for us? Simulation model and also the 3D model. Well, if you have the 3D models, that's always good. It's good because it makes it easier to show to the judges. It's easy for us to understand if we can visualize your car. And the simulation model, I'm not sure what you mean. Should we produce a model in which the powertrain is mounted in our chassis, mounted in a simulation model? Are you talking about like rigidal, like the rigidity or the torsional stiffness of the chassis with the powertrain? I'm not sure. That is not covered in this event. So that's more for the main event on the design. You talk more about structural integrity. So I guess this makes sense for the 3D model. I'm not sure how this makes sense or you would have to specify what type of simulation are you talking about. Yes, so structural rigidity models will not be covered in this. This is more for the powertrain EV concept. But I would say that for the main competition, for Formula Bar, make sure you have those simulations. Those are always very, very good, and it is for structural rigidity and especially for torsional stiffness. We have a lot of simulations on what is the torsional stiffness of the chassis, and people forget that the chassis have also other things mounted on the chassis which can contribute to the structural stiffness of the chassis. So it is common to use, for example, the battery pack or some other components of the car to contribute to the torsional stiffness of the chassis. But that is not covered in this particular event. So this event focuses on the EV powertrain concept. Hope this clears up your question. Thank you. So if there are any more questions, I don't know if there are any on the YouTube side, or if anyone here wants to ask a question.
There are no questions on YouTube. And I don't think anyone here has any questions either.
Okay, so I guess that's it. Thank you for your questions, and keep your deadlines in mind. So May 30, you still have 1 month to prepare all your documents, and I wish you the best of luck.
Thank you so much, Pedro, for making the time and for hosting this session. And thanks to everyone who joined in as well. If you all have any other queries, feel free to write to us. We will try to answer most of them as soon as possible. And thanks all of you once again, and have a great evening.
Thank you. Bye.
Bye.